Hello everyone, welcome back to another video of an average programmer. Today we'll solve the problem 35 of LeetCode, which is search insert position, and the objective is to insert a number based on its value, and we need to do this within a time complexity of order of log n. So luckily for us, the numbers are already sorted, so this is a straightforward binary search problem. So if you would like to know more about this algorithm, I'm going to leave a link in any edge of the screen so you can check it out. And let's see our examples. For our first example, we have that nums equals to an array of numbers including 1, 3, 5, and 6. And we need to insert 5. 5 is already in the array, so we just need to return the index of 5, which is 2. For our second example, we need to insert a 2. And 2 is not existing in our nums array, so let's just say that we will put 2 next to 1 and before 3. So the position of 2 would be in the first index. So for solving this, I'm going to first put the binary search algorithm. So we need to have our left and right boundaries, and I'm going to be declaring them as mutable variables because they are going to be changing their values over each iteration. So I'm going to be creating this, and we already know that we need to do this. We need to make iterations while left is less or equals than right, and in each iteration I will need to calculate my mid pointer. So we know that for doing this we can use math.floor, but I'm going to be using these icons that do the same thing as math.floor. So it's left plus right over 2. So if my number in the mid position is equals to target, I'm just going to return the mid position, and in case nums in the position of the mid pointer is bigger than the target, that means that I will need to change the boundaries. Okay, so since mid it's bigger than the target, this means that the target is at the left of the mid pointer, so I will need to change the right boundary to before the mid pointer. So I'm going to say that right is going to be equals to mid minus 1, and then I will have the other case of nums mid is less than target, so I will need to do the opposite with the right boundary. Okay, so now let's see our actual use case. So this is covering the case in which we have the number in our nums array, but we need to also consider this other case in which it is not in the nums array. So we need to find a good spot. So for doing this, I'm just going to use the mid position, and I need to be sure that mid is going to be in bounds. Okay, so let's just say if mid is bigger than or equals than 0, and mid plus 1 is less or equals than nums.length minus 1. This means that I can consider two numbers, but these two numbers, well, actually, this means that I will be considering two positions. If these two positions are in the range of the numbers length, I can check and I can see if my number could be positioned in that space that is between those two numbers. So I'm just going to verify if target it's bigger than nums in the position of mid and target is less than nums in the position of mid plus 1, then that means that we have found a good spot for our number. So we just need to return mid plus 1, which would be the case of inserting. Let's say that I'm actually not inserting the number, but we don't need to do anything else, so we can just return the index. Okay, so that's for the use case, but we also need to consider some other edge cases, which are that what happens if the number is bigger than the last element of our array, and what happens if our number is less than the first number of our array. So we actually do not need to execute binary search in that case. We can just go or get directly the values of those numbers in our array. So I'm just going to be covering those edge cases. If target is bigger than nums in nums dot length minus 1, then I'm just going to be returning the length. So it's going to be nums dot length. And if target is less than nums in the position of 0, I'm just going to be returning 0. And if I'm not able to find a good spot, I will just need to return minus 1, but we know that that might not happen, but let's see. So let's execute our code and see if it's passing the test cases. So we can see that for the first 3 test cases, our solution is good. So let's try to submit it and see the result. Okay, so this solution passed all the test cases, and we know that binary search runs in a time complexity of order of log n. So that's the time complexity of this. And I'm going to be leaving also the solution in the comments. And yeah, thank you for watching this video, and I'll see you in another one. Bye.